So as I mentioned in the earlier video, right? So CogVLM basically moves away from shallow alignment method, right? But what is shallow alignment method? That we will discuss in this part of the video. So basically, shallow alignment method was introduced earlier in the instruction clip and mini GPT-4 as well, and it was also continued in the Lava as well. So what it is? Suppose if we look into any visual language model, right? So there is a language model setting that is a Vicuna here. That is a language model or language model. And there is text prompts are there. That is what do you think of this logo design and such a kind of thing. So there is a Q former and VAT and linear layer. So this is basically a transformation that converts a visual input to the input that matches with the language space, right? So basically, it is connecting a frozen pre-trained visual encoder with the language models. So it is, yeah. So basically, there is a projection operator because when what VIT does is it tries to take image as input and it tries to give a visual features. But visual features may not align with the language space, right? So that's where either QFormer or the linear layer are sitting in between the language model and the VIT as a projection operator. So in order to map image features directly into the image embedding space of a language model. So that is the because that is the reason it is called shallow because uh, simply we are transforming the visual features to the LLM input space, but there is no deep fusion of image features and the language features over here. And furthermore, how it is affecting natural language generation capabilities of the LLM post training of the post shallow alignment, right? There might be a possibility that there could be a natural degradation in the performance of a natural language generation, right? So that's why it is called a shallow alignment method. So, but what are the challenges? Like, so as I mentioned, it is a lack of deep fusion between the visual and linguistic data, right? Because it's only taking care or towards the input side, right? So shallow alignment methods basically rely on the frozen language model weights designed primarily for processing text tokens. So significant mismatch issue due to the intrinsic difference between the visual features and the textual input space, right? So we are only partially aligning the image features with the uh, text inputs, right? That is a language input space. So visual features do not have, because of that one, right? Those visual features may not have a direct equivalence in the textual input, causing a fundamental integration problem, right? So these are the basic challenges associated with the shallow alignment methods. So and further, so as the reason is since it is a shallow, that is it is only taking care towards the input space, input side of the large language model, right? So, but in the large language model, there are multi-layer transformations happening. So visual features might tend to deviate from the expected input distribution of the deeper language model layers, right? This misalignment is particularly emphasized in specific tasks like image captioning because tasks demand various nuances such as writing styles and caption length. So, so such specificity can only be superficially encoded by shallow alignment methods. That limits the effectiveness of the vision language models, right? Suppose, for example, if you look at it, right? So we are adjusting image through a vision encoder and the projection map in the input space of the large language model. But they might undergo several, a lot of transformation inside the large language model. That's where uh, so the expected distribution, expected input distribution of the at the deeper layers in the large language model might deviate when it comes to visual language features that affects the effectiveness of the vision language model. That's what in a way we want to summarize. So, but how to address those limitations, right? So there are like if you look at it, right? Common training strategy in visual language models, right? So direct training of a large language models during pre-training and supervised fine-tuning, such as in Poly and ConVL, right? So potential drawbacks, what? So it can compromise the generalizability of the models, especially for the tasks that primarily focus on textual outputs. So LLMs traditionally pre-train because see when we try to do uh, vision adaptation, adapting a large language models to the vision task, right? Because of the shallow alignment, what it is doing, it is trying to affect the large language models in certain way. So what are those things? That's what I'm mentioning as a potential drawbacks in this approach. So they can compromise the generalizability of the model. That is, the natural language generation abilities might go down. So LLMs pre-trained on text-only data sets, right? So, so face challenges when transitioning to mixed data sets like Lion and Koyo because they're meant to handle text tokens. So this can affect the data distribution. Yeah, this kind of change in the data distribution can lead to catastrophic forgetting. That's where it loses its proficiency in the natural language generation. So, for example, there is one work proposed by Drew et al. So in that one, they have shown that adapting a 8B parameter language model for VLM pre-training resulted in 87.3 reduction in the natural language generation. So highlighting the severity of the issue. So in a way, if I want to conclude, right, when we adapt LLMs to a vision language models through a shallow approach, shallow alignment approach, right, there could be a possibility of catastrophic forgetting that affects the natural language generation ability of the large language model.